All right, today we're going to dive into a concept that's right at the heart of what makes Java so powerful, dynamic method dispatch. Now this might sound a bit technical, but it's really the secret sauce that lets Java pull off something called runtime polymorphism. Trust me, understanding this is a total game changer for writing professional, flexible code. And to get our heads around it, we're going to start with a pretty simple question.
So let's just think about the real world for a second. Picture this. You see a laptop sitting on a desk. You could point and say, hey, that's a laptop. You'd be right. But you could also say, hey, that's a computer, and you'd still be totally correct, right? You're just using a broader, more general term to talk about a very specific thing. The big question is, can we do that same thing in our code? And the answer is a big, loud yes. Absolutely. It's all possible because of one fundamental rule in object-oriented programming. A reference variable from a parent class is totally allowed to hold, or, point to, an object of one of its child classes. It's just like our computer reference pointing to a laptop object. This one rule, honestly, it's the key that unlocks everything we're about to get into. Okay, so let's see what this actually looks like in Java. In this first part, we're just going to set up that basic parent-child relationship that makes this whole thing possible. So let's imagine a really simple setup. We've got our parent class, we'll just call it class A, and then we have a child class, class B, that extends A. So B inherits from A. It's that classic parent-child structure, the foundation for everything we're about to do. And here is that fundamental rule in action. Take a look at this line of code. A obj equals new B obj. Now, I know it might look a little weird at first, but this is 100% valid. Let's break it down. The A obj part just means we're creating a reference variable called obj, and its type is the parent class A. But the new B obj part means the actual object being made in memory is a B object, the child class. So you've got a reference of type A, but it's pointing to an object of type B.
All right, that's pretty cool on its own, but now let's add a little twist. What happens when both the parent and the child have a method with the exact same name and signature? This is where we get to the real puzzle.
So let's update our classes. Imagine now that inside both class A and class B, we've added an identical method. Let's call it show. This, as you probably know, is called method overriding. It's when a child class gives its own specific version of a method that it inherited from its parent.
And this brings us to the million-dollar question. We've got our parent reference, obj, and it's pointing to a child object, B. Then we make the call, obj.show. So, which version of the show method actually gets executed? Is it the one from the reference type, class A, or is it the one from the actual object's type, class B? Go on, have a guess.
Well, the answer to that puzzle is all thanks to a really clever mechanism that Java uses. It doesn't make the decision when you compile your code. It waits until you actually run it. The easiest way to think about it is this. Compile time is like a grammar check for your code. But runtime? That's when the show actually starts, and the program is live, doing its thing.
And this mechanism is called dynamic method dispatch. It's the process where a call to an overridden method gets figured out at runtime, not compile time. The word you have to burn in your brain here is runtime. The decision is delayed until the very last second when the program is actually executing.
And this quote just says it all perfectly. To put it as simply as possible, Java doesn't really care that your obj reference is of type A. What it really cares about is the actual living, breathing object that obj is pointing to at that exact moment. So remember, it's all about the object.
Now, let's watch this in action. It's so cool. In step 1, our object reference points to a new A object. We call object.show, and no surprise, it prints in A show. Makes total sense. But now check out step 2. We reassign that very same object reference to point to a new B object. We call object.show again, and this time it prints in B show. And just to drive it home, in step 3, we pointed to a C object, and the same call now gives us in C show. The line of code object.show never changed, but what it did change dynamically, all based on the object it was pointing to.
So, you might be wondering, how on earth does Java keep track of all this? To really get it, we need to kind of peek behind the curtain and see what's happening inside the computer's memory.
So imagine you have two main areas in memory. There's the stack, and that's where our reference variable obj lives. Then there's the heap, and that's where the actual objects get created. So when we first say A obj equals new A, our little obj variable in the stack gets an arrow or a pointer that connects it to the brand new A object over in the heap.
Okay, now here comes the dynamic part. When our code then says object equals new B, a couple of things happen. First, a totally new B object gets built over in the heap. Then, and this is the magic, the arrow from our object reference in the stack breaks its connection to that old A object and swings over to point at this new B object instead. So now, when object.show gets called, Java just follows the new arrow, finds the B object, and runs the show method it finds there. Simple as that.
Look, this whole mechanism isn't just some neat little programming trick. It's actually the technical foundation for one of the absolute biggest and most important ideas in all of object-oriented programming.
And that idea is runtime polymorphism. Let's break down the word. Poly means many, and morph means forms. So it literally means many forms. It's the ability for one single action, like our object.show call, to have many different behaviors, all depending on what's happening at runtime. Dynamic method dispatch is just the name for the how. It's the mechanism Java uses to achieve this amazing thing called runtime polymorphism.
So what's the big deal? Why do we care? Well, because this lets us write code that is unbelievably flexible and easy to expand. Think about a graphics program. You could have a general shape reference, and you could just tell it to draw itself. Now, thanks to polymorphism, that one single command will work perfectly whether the actual object is a circle, a square, or maybe a triangle that you decide to add 6 months from now, all without ever touching that original draw command. That is why this is so powerful. It really is a cornerstone of good design.
Now here's a really important rule to remember, both for your exams and just for writing good code. This whole thing only works because of inheritance. You can't just assign an object of some totally unrelated class to that parent reference. For instance, if you had another class, say class D, that did not extend A, trying to write object equals new D would just give you an error right away. The classes have to be in the same family tree.
Okay, let's do a super quick recap of the key points. Number 1. A parent reference can totally point to a child object. 2. When you call an overridden method, Java decides which one to run at runtime. 3. That decision is based on the type of the actual object, not the reference. 4. This whole process is called dynamic method dispatch. And finally, number 5. It's the engine that powers runtime polymorphism.
So we've covered the how and the why. The final question really is for you. Think about some code you're writing or a project you're working on. Where could you use one single reference to manage lots of different types of objects? How could that make your code cleaner, more powerful, and way easier to update in the future? That's where you'll find the real power of what we've just talked about.